Hello, today we're going to be verifying trigonometric identities, which sounds pretty complicated, and to be frank, is kind of complicated. But if you take deep breaths, do one step at a time, it's going to be okay. The first thing I should point out is that a trigonometric identity is an equation, but in order to verify one, it's like a proof. We can't assume that they're already equal when we're trying to prove that they're equal. So we're not allowed to do both sides. We can't add to both sides or subtract on both sides. We have to select one side, and we're going to pick the most complicated side. The one that looks the worst is the one we're going to pick. And we're going to start there, and we're going to simplify it. And hopefully, when we simplify it, it just naturally flows into the other side. There is sometimes it's not quite so smooth, and so there is a trick to if that doesn't work out nicely. But we'll see that when we get there. And there's a trick for getting around that. Let's get right into examples, because there's nothing new in this lesson. We're going to assume that you know the basic trigonometric identities, that is the reciprocal and quotient identities and the Pythagorean identities. If you don't know those already, you're going to want to learn those before you try to tackle this video. In our first example, we're going to try to verify that tangent squared of x plus 1 divided by 1 minus sine squared x is equal to secant to the fourth power of x, which is just kind of weird. And you might look at that and say, why in the world should that matter? And how would I know that? You wouldn't know that, and it only matters in as much as I happen to know they're the same, and I'm going to make you prove that they're the same. Well, in this case, I'm going to prove they're the same. This is a proof, so when you're doing work for this, you want to make sure you take it one step at a time. We already know what the answer is. The answer is secant to the fourth of x. Oh, I forgot to pick a side. This side, it's got a fourth power on it, but this side has squares and a big fraction. So this side has clearly got more going on than this side, and this is the side I want to start with. When I'm all done, this should say secant to the fourth of x. That's how I'll know when I'm done. The answer is not what concerns us. It's the process. I'm not going to require my students to make a two-column proof, but this is a proof. You need to do one thing at a time. You need to make sure each step is justified. I'm going to justify each step so you can get the hang of what we're doing, and honestly, it's not a bad idea. But I'm not going to require two-column proof format. In this case, we're going to start on the left side. So I've got tangent squared x plus 1 over 1 minus sine squared x. And remember, I can't use the fact that I know these are equal anywhere in my proof. This is the given. This is the left side of the equation. I'm going to try to get rid of this. The first thing I notice is that the place I'm going is not a fraction, and this is. So tackling the fraction is my first priority. And actually, I recognize the bottom here is a difference of squares. So I know that I can use Pythagorean identity on that. What I know is that sine squared plus cosine squared equals 1. So 1 minus sine squared is going to equal cosine squared of x. So that'll be my first substitution. It's a Pythagorean identity. And that's going to change the bottom to be cosine squared of x. Well, that's much better than it was. It may not look like it to you, but I know it is. The addition and subtraction on the bottom is the worst. Let me leave the top for now. One thing at a time. Then I'm going to do a Pythagorean identity on the top, because I happen to recognize that one. Tangent squared of x plus 1 equals secant squared x. So I'm going to do that substitution on the top. Top becomes secant squared. Bottom is cosine squared. I can get rid of this denominator now by multiplying by the reciprocal. So this is secant squared of x times 1 over cosine squared x. That's multiplied by reciprocal. If you like, it's also the definition of division. And now I happen to know the reciprocal identity for 1 over cosine squared is secant. Oh, I guess 1 over cosine is secant is what I know. So 1 over cosine squared is secant squared. And now I have secant squared times secant squared, which we all know is secant to the 4th power, because that's just multiplication. Now I have, here at the bottom, I have taken this, and without using the right side, I have an ironclad proof that this is the same as this. So I'm going to write at the bottom QED, which is Latin. You can just remember it's QED. What was to be demonstrated? It's quad errata demonstrandum. But QED means I'm done with my proof. And here's my proof. I take one side, I simplify it until it looks like the other side. Justifying each step is probably a good habit. Let's try another one. So for my second example, -2 times the cotangent x equals sine of x over 1 minus cosine minus sine x over 1 plus cosine. Oh, I did that backwards. The first one should be plus, and the second one should be minus. Sine of, yes, okay. -2 cotangent x equals sine of x over 1 plus cosine x minus sine of x over 1 minus cosine of x. Clearly, the one on the right is the more complicated, so I'm going to take it and start messing with it. I want to put those fractions together. This has one piece, not two terms. So I definitely want to put these together. The denominators are not the same. I don't have a like denominator. I need to make a like denominator. Let me skip ahead a step. I happen to know what my like denominator will be because these are exclusive. So it's going to have a 1 plus cosine of x in it, and it's going to have a 1 minus cosine of x in it. So if I'm looking up here, this one has a 1 minus cosine. I have to multiply by 1 plus cosine. Now I'm not allowed to multiply on both sides, but I can multiply by 1 anywhere I like all the time ever. So I can multiply the bottom of this fraction by 1 plus cosine of x to make it my least common denominator, as long as I also multiply the top. And similarly, although I don't have room, I'm going to multiply this one by 1 minus cosine x over 1 minus cosine x. I really should have done this on the next row. And that gives me sine of x minus sine of x times cosine of x over 1 plus cosine of x times 1 minus cosine of x minus sine of x plus sine of x cosine of x over 1 minus cosine of x times 1 plus cosine of x. So when I add these together, or really subtract these together, I'm going to get sine minus sine, which is going to cancel very nicely, and negative sine cosine minus sine cosine, which gives me -2 sine x cosine x. Now, if you've never done this before, you probably won't understand immediately why I'm like, oh, sweet, -2. But I'm very happy about this -2 because it's in the answer I'm looking for. So this -2 is a good sign. It means I'm headed in the right direction-ish. So I have this sine cosine, though, instead of the cotangent. I'm going to need to deal with that. Let me go ahead and multiply my bottoms together. I got excited when I saw these two because I recognized this pattern is going to give me a difference of squares on the bottom, which, as we learned before and saw earlier today, difference of squares usually is a setup for a Pythagorean identity. So I made an LCD. I subtracted my fractions together. And now I'm going to, multiply was this step. Now I'm going to use a Pythagorean identity substitution. So let's see, 1 minus cosine squared of x is going to be equal to sine squared of x. So the bottom is now sine squared. And the top is negative 2 sine x cosine x. Hey, look at that. Reduce. We're getting near the end now. One of the signs on the bottom will reduce with the sign on the top. So I've got negative 2 cosine over sine. And if you remember your quotient identities, cosine over sine is cotangent. Now I'm done. That's where I was headed. Cotangent of x. Negative 2 cotangent x. There it is. Verified. Example number 3. Sine of x over secant x minus 1 equals cosine x times cotangent x plus cotangent x. This one's kind of a tougher call because the left side's got the fraction, but the right side has cotangents and a bunch of them. And cotangent is one of our quotient functions, right? Cotangent is cosine over sine. So that'll actually produce a fraction for me if I want it. Secant on the bottom. Oh, this is a tougher call than I thought. I'm going to start with the one on the left, the fraction. But, wow, it's tricky. I could totally see this working the other way around as well. It actually doesn't matter which one you pick. You should be able to make a chain from. It's just a lot easier. Like, things will occur to you more easily if you start with the more complicated side. So, fractions. All right. We got sine of x over secant x minus 1. Now, one of the things I'll see students do is try to move that secant to the top as a cosine right now. But as long as it's part of an addition or subtraction problem, you can't just do the reciprocal of secant up here. If you do the reciprocal, you'll end up with a complex fraction, which there are worse things. So this may get worse before it gets better. But let's go ahead and do that. We're going to turn everything into sines and cosines. So secant is 1 over cosine minus 1. So that is a reciprocal identity. Now I have a fraction inside a fraction, which is bad. So I'm going to multiply by cosine over cosine. And that's going to get rid of my fraction. Now on the top, I get sine times cosine. I'm allowed to multiply by cosine over cosine in case you're wondering, because that's 1. And multiplying by 1 doesn't change things. On the bottom, I have to distribute. Cosine times 1 over cosine is 1. And so this becomes cosine. Sine times cosine over 1 minus cosine. Looks like to get rid of the bottom, I'm going to need a Pythagorean identity. I was hoping that might do something. But probably should have done it from up there. But I'm going to need to produce the difference of squares. So now I'm going to have to multiply by 1 plus cosine over 1 plus cosine, because that will produce a difference of squares on the bottom. You know, I see it now. I totally should have done that way up here. And multiplied by secant plus 1, I'd be done by now. So the bottom becomes 1 minus cosine squared x. The top becomes sine x cosine x plus sine of x times cosine squared of x. Interesting. The bottom now, Pythagorean identity. 1 minus cosine, we've seen a few times already tonight. That's sine squared. So this is actually one big fraction, but the place I'm headed has actually two terms. So I'm going to split this fraction into the sum of two fractions. Sine of x cosine of x over sine squared plus sine of x times the cosine squared of x over sine squared of x. That's how fraction addition works. I could write fraction addition over here. I'm not going to. This reduces. So sine, this becomes cosine over sine. Oh, that's promising. That's cotangent. And this one is cosine squared over sine, which is the same as cosine times cosine over sine. Which gives me, by the quotient ID, cotangent plus cosine times cotangent, which is where I was going. Yeah, I really should have started with multiplying by secant plus 1. We got there. Turns out there's several ways to solve most of these. I kind of want to do that one backwards. If anybody wants to see it backwards, let me know. Maybe I'll do it. Next example. Cosine x times secant squared x times tangent x minus cosine x tangent cubed x equals sine. Well, clearly the left side is more complicated. Looking at it, I got tangents in there. I should probably factor out that tangent and that cosine. No, first I'm going to turn everything into sines and cosines. So I'm going to use my quotient and reciprocal identities because I'm going to turn everything into sines and cosines. Cosine is already cosine. Secant is 1 over cosine squared, and tangent is sine over cosine. Cosine is already cosine. Tangent cubed is sine cubed over cosine cubed. So these are right away going to cancel a bunch. This cancels with this. This is going to cancel with one of those. So I've got sine x over cosine squared minus sine cubed x over cosine squared. That's excellent. Reduce. Now these already have a least common denominator, so I'm going to subtract, which gives me sine of x minus sine cubed of x over cosine squared of x. I already know what I'm going to do on the top here. I'd like this to be 1 minus sine squared, so if I factor out a sine, that leaves 1 minus sine squared. So factor, and then I know 1 minus sine squared equals cosine squared. That's a Pythagorean identity. So this Pythagorean identity means I've got cosine squared over cosine squared, which will reduce. And sine x, which is what I wanted. No. No, I think I'm done. So these will take you a while to get used to. So take it nice and easy. Don't wait until the last minute to try your homework because that will be very frustrating. And let me know if you need help.